All right, welcome everyone. Very pleased to be taking you through AI in the math classroom, empowering educators and students. So I have a lot to get through today. Actually, we'll get straight into it. And I'm just going to need your help to kind of focus me because I can ramble on forever about this topic. So there'll be a poll soon that will help us get focused on the things that you want to learn the most about. But with that, let's get to Mathspace. Who we are at Mathspace, we believe that every student can excel at maths with the right help at the right time. And our mission at Mathspace, why we come to work every day, is we want to be the right help at the right time for every student. Okay, I'm going to need your help to set the agenda. Like I said, I can go on. There's like 5 topics that I want to talk about, and I could go for an hour on each one of these topics. So I will set up a poll, and hopefully this works for me. And you can tell me which topic you are most interested in learning about. It's multi-select, so you can select more than one. Okay, we'll give you a minute to go through that, and I will try and apportion the time I spend on each according to kind of your levels of interest. Awesome, lots of responses coming through, and lots of doubles as well. We have more responses than we have people, so I think. All right. So that's almost a minute. So I will now end the poll and share the results. Okay, so 82% want to know about how they can use AI as a teacher. Awesome. We're going to go through some examples of that for sure, and I'll make sure I cover that whole part. A demo of Milo AI chat's capabilities was next best. That's the last thing on the agenda, so I will make sure I will try to make sure I save some time to really go through the capabilities of Milo chat. And then also how Mathspace approaches product, and then still some significant interest in just how AI works and the latest AI developments. So that's where I'm going to start and I'll try and go through that quite quickly so we can get to the media stuff that you're more interested in. Awesome. Thank you so much for helping me set this agenda. Okay. All right. So we're going to go through this really quick then. How large language models work. It really is the innovation of our generation. So I think it's very important that as math teachers in particular, that we have some idea of how they work. So we'll go through this really quickly. Basically, these are statistical parrots. So you can imagine that we have the words in the dictionary. Let's say there's 600,000 of them, and that we number them all across like that. The way an LLM works is we assign a number to every single word. Say, hey, how are you? Could be the numbers 25, 35, and 75. And all LLMs are doing is guessing what the next word is. So if I just have R in a 2-gram model, it's just like a 2-word model, what's the likelihood of the next word being you or they or things or fine? There might be equal probability. Are you, are they, are things, are fine. They all kind of make sense, equally likely in a 2-word kind of. As you increase the number of words, things can kind of start to get more interesting. So if you say, how are, then the chances of you being next could be a much higher percentage. So the number associated with you might be a lot higher to come up as a next thing. And this is what large language models are doing, except they're doing it with a really long context. So what if I said, hey, how are, in a 4-gram model with 4 words, then the you gets even higher, the likelihood. Okay, so these things seem really smart, but all they're really doing is completing the next word. And so there was this breakthrough in a 2017-2018 paper that basically led us to have an algorithmic improvement or a computational improvement that could do this on a really, really, really large scale. And that's where things started getting interesting with these large language models. Because if you have a whole bunch of context, then guessing the next word can get really interesting. So for example, if I have Ben likes to play and I want to know what the next word is, it's highly unlikely that fetch would be the next word. Might be play soccer, play footy, play whatever it is. fetch might not be like the first word that comes to mind. But if you have the prior context that my dog's name is Ben, he is a big dog, then when it says Ben likes to play, then the probability of fetch being a good fit as the next word becomes much, much higher. And that's basically what LLMs are doing. It's an autocomplete, but it's just super smart with the autocomplete. So that's at its most basic level. It's kind of GPT-2 level. And then some new things kind of added on top. So some steering. So this is GPT-3, where you start to be able to steer. How do you steer in GPT-3? Well, if you're just doing a word complete and you throw a Q at the front of it and then an A at the end, reading all the data on the internet and trying to guess what the next word is, like, it's likely going to be the best answer to this, which is Paris is the capital of France, for example. So that will the next words might be. So that's kind of the very basic level steering. It started with these Q and A. And then we moved on to these fine-tuning and reinforcement learning. So fine-tuning is to say, okay, now we've got all this data. We need to guess the best next word. But before we do all that, let's fine-tune with a data set of human curated answers. So if you have these human curated answers, large data set of like this, for this question, this is a great response. For this question, this is a great response. For this question, this is a great response. It makes those autocompletes work a lot better. So this is kind of the innovation that led to GPT 3.5, where it kind of took the world by storm. And then reinforcement learning with human feedback is kind of a similar approach, but this time it lets the model generate a number of answers, and a human comes in at the end and ranks those answers. So if the model gave 4 different answers, A, B, C, D, a human comes in and says, I like D better than C, better than A, better than B, and it trains this kind of reward model. So in the future, I'm going to pick answers that are more like D, which the humans like. And through this, ChatGPT was kind of created. So it's not that difficult. Even the maths behind it is really not that difficult. What's really changed, like why did nobody see this coming, is just the scale and speed of the compute, the scale of the data. So just get all the data, like all the data in the world now is in these models, and the ability to compute. So the basic advancements in computational and GPUs that allow us to really scale this to go at a higher scale. And amazingly, it has this creativity about it. You can actually steer it, and the steering that comes through, and that's what large language models are. So it's not real intelligence. It's really clever. It's not real intelligence, but is it not real intelligence? This is kind of where it gets interesting. So this was when I had the aha moment with large language models. The blue bars that you see there is GPT 3.5, and these are scores on various tests. So where's the math one? So there's the SAT math one over here. I think you can see my mouse on the screen. And then the green is the GPT-4. So going from 3.5 to 4, which was maybe 3 to 6 months later, adding nothing but extra data and scale. So no extra algorithmic improvements, nothing like that. It was just like, let's throw more data and more computational scale at this, more kind of servers and GPUs in the cloud and these cloud farms that are doing this. And suddenly you're getting emergent capabilities. I mean, the bar exam, the legal exam in the US, we had 3.5, which is pretty dumb, only gets 10%, suddenly scoring 90% without anything changing except scale. And there was kind of also like no end in sight here. Like, can we just increase more data and more scale and it will just improve? And then the other really interesting thing that came out of this is it's just a word complete, but it's starting to learn to reason. So math, as an example, is something where you need to reason. So you can't kind of answer a question just by guessing the next word. And these were what they call emergent capabilities that were just developing in the models. So for me, this was an aha moment. It's like, this is a real kind of game changer in terms of what it can do. And you can see those results as you see going from ChatGPT 3.5 to 4, etc. And then similar techniques can be used for images, audio, writing code, because an image is really just, instead of what's the best next word, it's what's the next RGB value, like what color pixel in the next pixel. And if you can train it based on all the images on the internet of like what good looks like, then it can start to guess that for you. We have a question. When you talk about scale, are you talking about the number of patterns or word orders? So two scale. Scale is just the amount of data. Okay, so it's the amount of data that's coming in. So we can use, right now it's like all the data on the internet. Pretty much scrape everything. So that's one scale, and then the other scale is scaling the compute. So the actual computing power behind these models. That's all it is. So it's not algorithmic change. It's not like, oh, we're making these things smarter. We used to have to train AI by improving the algorithm. We're not doing that in these cases. There's certainly algorithmic improvements, but the big features were data and scale of compute. So can it be applied to images? It can be applied to audio. What frequency, wavelength, and amplitude fits best in the next millisecond? Choose that. And then that's how you can kind of develop great music or voiceovers or translations to a different language. And that's why you hear, if you've heard the realism of ChatGPT's voice mode, it all just comes from the same kind of patterns, but applied to audio. And then similarly for writing code. Writing code, there's lots of code, the data, there's lots of code, open source on the internet. And it's just a case of saying, well, code is just completing the next words. That's a really great use case for AI. Okay, just some examples. Can you give me a picture to celebrate maths teachers at a conference learning from each other? This one I used at a conference I presented at last year. And it's like, okay, it looked pretty nice. What about make it in the style of Rembrandt? Without the T, I should have put the T in there. And look at the kind of quality of the images that are coming out of these models now, all by guessing the next pixel. So this really, pretty dumb model that just like is autocomplete on the next word or the next pixel is coming up with these amazing images, essays, or whatever it is that you want to do. Yeah, here's a little example. I don't know if I'm sharing sound. Maybe I am. I'll play it. Okay,
Este año hacemos un desafío de maestros de matemáticas diferente a otras competencias. Normalmente, en competencias de matemáticas, premias el logro estudiantil y de...
That's me speaking Spanish. I do not know how to speak a word of Spanish, but if you take a video, I spoke in English, and then we took that video, and one of our engineers was like, hey, Mo, you want to see yourself speaking in Spanish? And he put it through some AI tool, and it comes back, and now I'm speaking Spanish. It translated the English. It changed my mouth movements to sync with it. And this was like over 6 months ago. So these tools have only gotten better, and it's quite scary about where it can go. When would I accurately understand handwriting? We will come to that. Well, I'll give you an example of one soon. Okay, so moving on really quickly to what's the latest with large language models. Who are the major players? ChatGPT was the one that kind of brought it to the forefront, but Meta, Facebook is doing a model. Anthropic, Claude has a great model. Google is doing a model called Gemini, which is great. Twitter X is doing a model called Grok, which is great. There's a startup, French startup, I believe, doing a Mistral AI. So there's lots of kind of players, but these are probably the major players in the market. And they all have different... They don't just release one model. So you're probably familiar with ChatGPT. There's GPT-4, GPT-4o, Turbo, and Google has their Gemini models and have different sizes, different prices, different speeds. And we're kind of really staying on top of all these different models and what all of them can kind of do, and which are the best at various aspects. And some of them are better at coding. Some of them are better at math. For example, this is a leaderboard where there's a kind of, they analyze on a private data set, which is interesting because you can actually train these models on the data sets. So you don't want to do that. So you've got a private data set that the models don't know about because they pretty much know all of the internet. And then you test to see which gives you the best responses. So on instruction following, the Claude's model is actually winning that race. But you can see the scores are really, really close. At the top of the leaderboard, the scores are really, really close. And when you look at the confidence intervals, 87, but plus or minus 1.64, it's really hard to say that it's always better than Llama, which is the open source Facebook one, or Gemini or GPT-4o. They're all going to be really quite similar. On math, again, Claude seems to be a little bit better than GPT. On safety, adversarial robustness, Gemini, Google's model is kind of the best on that one. So you can see, you can kind of get an idea of like, there's all these different models now. So we're not just talking about ChatGPT, which is kind of the one that came to the front, but all kinds of different models that are good at different things and offered at different price points and things like that. Now, if we're going to talk about, AI and math, we definitely need to talk about the new model that OpenAI just released last week called O1. I should probably have a poll just to see how many of you are on top of this. But anyway, maybe you can say in the chat if you've heard of the O1 model. Before we kind of talk about what O1 is, let's learn a little bit about prompting techniques. And what better way to learn about prompting techniques than to just ask ChatGPT, give me a brief summary of the various prompting techniques. And this is a way that I use ChatGPT. And one of the things that I want you to get out of this is just to encourage you to use whatever your favorite LLM is, ChatGPT, Claude, the open source ones. And anytime I have a question, my first thing to do is just use ChatGPT as a thought partner. So as I was developing these slides, I kind of went like, I want to talk about O1, but to really talk about O1, I need to teach them about chain of thought prompting. Okay, hey, can you give me a brief summary of the various prompting techniques? And here they are. So prompting techniques are basically what you tell ChatGPT, the instructions you give ChatGPT or other LLM to get it to give you the desired output. So the most basic thing is just ask a question just as it is. That's called zero-shot prompting. You just ask the question. One-shot prompting is you give it an example. So I want you to do this for me. For example, here's how you go about it. Few-shot prompting, you give it a few examples. Now, these are all kind of fairly simple. Things get really interesting when you do chain of thought prompting. This is where you encourage the AI to break down its reasoning or thought process. And this helps the AI to get better because it has longer time to think as it's working through the tokens. So a token is kind of like roughly a word. So when it's that you see it streaming and it's going, what's the next word? What's the next word? What's the next word? As it's doing that, we said before that those words that it has give it extra context for the next words that might come up. And simply by doing this, through it actually reasoning out loud, just thinking out loud and actually typing out those words for you, it's getting smarter at what to do next. So O1 really leverages this chain of thought, and it's something that you should, whenever you file like, ChatGPT is not giving me the answer I want, you have follow-up questions where you're asking it through step by step, and you can see it kind of improves. So it's a really good thought partner for doing things like that. Another strategy, again, I've asked ChatGPT, is called response sampling, where you take multiple responses and you get the best one. So you ask an AI, give you 5 responses, or you ask 5 different AIs, and then you ask a 6th AI to say, look at all those 5 AI responses and pick out the best one. Another really great way to get better responses. So because there's this creativity and divergence in answers in AI, you can say, okay, let's get a bunch of responses, diverse outputs, evaluate or rank them and pick the best one. You can also combine insights from multiple AIs. So using these kinds of methods, just last week, OpenAI released O1. So it's the kind of latest variation of ChatGPT, the latest model. And the results are quite remarkable for mathematics and reasoning. And basically what they've done at a high level, and a lot of this is proprietary, they don't share. OpenAI is kind of becoming a closed AI. They want it to be open source AI, but over time they've moved away from that. And so the idea here is that while you're training, if you spend more time on the training, so these computers that are analyzing all this data, you start to get better results. And also if you spend more time at the time of actually asking the questions. So at the test time when you're giving it, it gets better results. So I'm going to give you some examples, just like, well, how much better? This is GPT 4.0 on a Olympiad math competition. Just 13.4% accuracy. This is O1 preview and O1, slight variations of the model. The one that's available to the public right now is O1 preview. O1 is kind of still locked away behind the scenes. But you can see the jump on its ability to answer really hard math problems, like Olympiad level math problems, has gone from being quite poor to being very, very good. Similar with competition code and PhD level science. Again, you're going from 56% up to 78%, better than an expert human. So really phenomenal results. And so AI is just continuing to get better and better. And so if you haven't quite got into it yet, it is definitely, hopefully this will inspire you to just start to explore what's out there. Okay, I won't go through those, more of those. Okay, let's get into the practical applications of the maths teacher, where a lot of you wanted to spend the bulk of the time. Okay. So what are some practical applications for math teachers? Generating practice problems for, you know, a worksheet or things like that. I mean, they're generally pretty easy to do anyway, but when you're looking at getting kind of interesting real world context and things like that, then it gets really good at that. So I've got a quick example for you of ChatGPT with a test that I did on a real world context. So I gave it this prompt. I'm looking to write a context around a math problem where students are required to graph a logarithmic equation, but for a restricted domain. Okay, so it's a really kind of specific thing. And how do I turn this into a real world problem? I could, you know, maybe come up with a real world thing, and you give me 15 minutes to think about it. This is the O1 preview. It just needed 24 seconds to think about it. So certainly that's one of the differences. It's not like ChatGPT where it just kind of gives you the answer right away. It needs to think first, and this is what makes it smart. I'll just show you what the thinking is. So they don't give you the full thinking, but they give you an insight into the thinking. They summarize the thinking that's going on. So in that 24 seconds, ChatGPT is clarifying the function, determining the domain, taking a closer look, brainstorming viewpoints, etc., piecing things together, all of that in 24 seconds before it responds. And this is actually what's making it smarter. Normally, when ChatGPT it's just kind of going for like, what's the next word immediately, and it's not taking the time to kind of think ahead and do that chain of thought reasoning, lay it out, revisit, sample different things, and say maybe not that one. Let's go with this one. That looked like a better idea. They've incorporated that into the model now, and the results are kind of phenomenal when it comes to its ability to reason. And this is the problem that I ended up coming up with. An acoustic engineer is studying the sound intensity. Is one intensity of machine A and machine B, and what's the difference in sound levels? So you've got these decibels, and so by doing this, you have your part A, B, C. There you go. That would have definitely taken quite a bit of time to come up with something like that, and ChatGPT kind of comes up with it. It's not necessarily perfect or right. You still have to do all the checking and all of that, but it definitely is a great thought partner for you to as you're going through. So that's a really great use case, hopefully a practical use case that you can take away. I know teachers already really time poor, and you got to spend time writing exams, and you want to make sure they're not the same questions as you had last year because kids love to cheat and all of that. These are great ways. You can put in the last year's exams and say, can you write variations of these that are different, etc. So really good use case for you to save you time. And with the new capabilities of O1, could be a really interesting one. Someone asked about reading handwriting. Let's have a look at this example. So I pulled this off the internet. Okay. It's not a real thing, but you can see, okay, it's a worksheet and students are just adding numbers together, basic addition. And I gave it this prompt. My student self-marked this worksheet. Can you confirm he was accurate? If not, identify where he is wrong for me to double check. So it read through that. It had issues initially accessing the image, but then it figured it out. And it gave me the 5 questions that were marked as wrong, and gave me what the correct answer is, and said in conclusion, the student correctly identified the errors in these problems and the self-marking was accurate. And then I asked, were all the others correct? Since you're so good at that, were all the others correct? And so, by the way, with this, I'm using ChatGPT 4.0. I'm not using the new O1 preview model because it doesn't support attachments. It can't read images yet. So, but ChatGPT 4.0 is fine at doing this. And so you can see, yep, it goes through and verifies the correctness of all of them, except for this one. So it says, yeah, they're all correct, except for this one. So I went to have a look at that one. 454 plus 959, 1413. The student missed this one. It should have been 1418. The student provided 1418, but the correct answer is 1413. Let's go back to that. And it thought that the student here had written 1418. But they did actually write 1413, so they're kind of fine. So you can see, I mean, that's a mistake that a human could make as well, but that's the level of ability that it has to kind of read these things. So certainly its ability to read images, translate, etc., is transcribe written text is a very powerful tool, and hopefully something that you could potentially use and find useful. Something else that it's really good at that we've used it for at Mathspace is as a thought partner for developing lesson plans. So we've got a lot of lesson plans inside Mathspace, and it's been really good just as a thought partner. Like, what would you do to help an English language learner to learn this particular topic? And it'll give you some vocabulary exercises and things like that, some special needs support, etc. Again, it's not good enough it's going to hallucinate, it's going to come up with things that aren't great ideas, etc. But it's really good as a thought partner. You can kind of go back and forth with it and come up with some really good ideas for lesson plans. And we found really similar for developing engaging group activities. So you want to teach a particular concept, but you want to try and turn it into a group activity, and you're not sure what a good way to do it is. It's just a great thought partner as you do it. The output's generally only as good as your input, so you do have to kind of take the time to really look at what you want to achieve out of it. But it certainly speeds up the time to kind of come up with those things and be creative with you. So there's some really great use cases for it. All right, I'm going to pause for questions just when I finish this section, but so feel free to kind of put in your questions and I'll get to them in a second. One thing I was super interested in knowing is like, how good is O1? Can it solve like really tricky extension 2 problems, specialist math problems? And so I Googled what's hard questions on the VCE specialist math exam. And I found this was the first thing that came up, was like, oh, there's a video there. It's like, well, I kind of wanted the question all nice for me. But then as I do, I kind of went like, hey, I can pull out the video from. So what I did is I screenshotted it. Look how bad that screenshot is. I screenshotted from the video of the whiteboard and I said, transcribe this. So I asked that to ChatGPT 4.0 and I got a perfect transcription of the question in there. And then I said, okay, now that I've got that, I'm going to put it into the O1 model and ask it to answer the question. And it thought for 5 seconds, did its little analysis and wrote a detailed response, and it was correct. That is the answer. At least that's how the student solved it on the whiteboard in that video. So we're getting to like really, with O1, the ability to have some really difficult questions. Then I went, hey, let's try the hardest New South Wales Extension 2 problem from last year. It was like an infamous problem with complex numbers. And I put it in there and it thought for a full 55 seconds. That's the longest I got it to think so far. And it got the wrong answer. So it made a valiant attempt, but failed at the answer. So certainly it's not foolproof or anything like that. But its ability on answering difficult math problems has really, really improved. Okay, I'll go to some questions on this section. Can you get AI to produce quality math diagrams with math lessons, worksheets, etc.? Nope, not yet. Something's, we've definitely tried to look at Mathspace, and its abilities on math diagrams is not very good at generating those. Okay, any other questions? I think it looks like Fadi's answering a bunch of them. Are we still teaching maths to kids in 5 years? I think teachers are, for me, I think teachers are the safest job there is. It's the human connection that teachers have with their students. I think the way we teach might change. The ability for them to use tools like Mathspace to help them solve very particular things inside problems. That's going to get better and better with just the computer and AI and what it can do. And already Mathspace is doing a lot of that. But teachers' ability to just develop rapport with their students and just the human side of the teaching, creating creative, engaging activities for students and getting them engaged in the classroom. I can't see a time where a robot is creating the same kind of engagement that a teacher can in the classroom. But certainly it will elevate a teacher from being somebody that's just doing grading and just, giving lots of questions to somebody that's more strategic in how they spend their time and doing more of the group work, doing more of the problem solving and that kind of thing. All right. We'll move on to the next section. How does Mathspace approach AI in product development? One of our most important principles is to co-design solutions with educators. So we really, something I've learned over the years, I've been doing this for 15 years now, is you can think you're creating this awesome new tool using all the latest technology innovation. If it's not practically going to be used by teachers in the classroom and students, then you're wasting your time. So that's one of our first principles. And we really believe that education, technological innovation on its own is kind of interesting, but not really going to move the needle. And similar with education innovation on its own, but where we want to sit is really at the intersection where we're working with innovative educators and adding that technology layer on top. And more than half our team at Mathspace are educators, so it's like something that we definitely have that kind of empathy of what teachers are feeling and what the students' needs are. I went on a fact-finding mission last year. I visited over 100 schools and discussing AI with educators. So I'm personally leading the AI team at Mathspace. It's one of the funnest things to do. It's like, I feel like it's my calling. It's I'm very, very involved with the kind of product roadmap and the kind of approach that I'll share here is something I'm sharing from kind of first experience. In talking to teachers, they had these 5 major concerns with AI in education: cheating, hallucinations. Hallucinations means that AI is just giving wrong answers, making things up, teacher visibility and teacher control, and then safety and equitable access. So, I think these are self-explanatory, so I won't really go through them. I'll get into the kind of parts, that you are most interested in. So that's principle 1, to really work with educators and learn from educators about what their needs are. And then our principle 2 is really creating space for experimentation. So at Mathspace, when ChatGPT was released February 10th, 2023, I 1 month later sent out an internal memo to the team and just said, hey, I've got ChatGPT Plus for everybody. Start using it, just start experimenting. It's good things will come of it. I don't know what we're going to build with it, but I want you all to have access because this is an awesome tool and we're going to learn a lot just from practicing it, from experimenting with it. And through that kind of approach, using the ChatGPT and Mathspace, kind of putting the power of them together, Milo was born. And I think a lot of you have started using Milo. And so for those who don't know what Milo is, we went from going on one-way chat inside Mathspace with hints and videos to having this 2-way conversation where students can actually ask questions, and Milo has the context of the question and all the steps that students have put in as they go through. So this was kind of, and we really wanted it to be a Q&A format, question and answer format, and we kind of have done a lot of work over the last, I don't know, we probably released it a year ago, over the last year, to really improve the conversation that Milo has with students. And we want to address all the key issues. So on the cheating, we really make sure that if a student does ask for the answer, that Milo steps in and says, as a math tutor, I really need you to try. So you probably see we've gotten a lot more aggressive, trying to pick out those times where students are just kind of being lazy and getting Milo to do the work for them. So I've done a lot of work on that area. On hallucinations, this is obviously one of the biggest problems with AI, and at Mathspace, we do a lot of work on this to basically all those prompting techniques that we talked about, 0-shot and 2-shot prompting and chain of thought prompting and all of those, we kind of incorporate them into how Milo operates, and we provide Milo with a whole bunch more context. And we're lucky enough that with Mathspace, all our questions have hints and step-by-step solutions. So we incorporate that into the context so that when Milo answers, he's got the context of the hints that we would use, how our team who had developed these hints would help students as they progress through, and then leveraging that to go through. And Milo's still not perfect after all of that, but the accuracy now is getting into like the high 90s in terms of the percentage of time that Milo gives correct answers. And still every now and then Milo will struggle, and the interesting thing, it will often struggle on like the most basic arithmetic. And that's just the nature of large language models. They are just predicting the next word that don't have any mathematical capabilities built into them. So that's a big part of how we deal with hallucinations at Mathspace. Teacher visibility. So here's a real life example of a problem that a student has done. And you can see that this is a teacher's scorecard as they're reviewing the student's problem. So when a teacher reviews and sees, the student entered 67, and then they might have got the right answer at the end, they're also able to see all the help that they got as they were going through that, as you can see there. okay? And also control, so teachers can turn off Milo on a particular task. Safety, if there's any messages that are kind of dangerous or swearing or anything like that, then we block the conversation. And we'll see in a second, we've also done a lot more work on ending conversations that are off topic, just to make sure that students are on track. And then equity is something that teachers care a lot about. We offer large-scale free trials. It's actually currently for all term 3. We gave a free trial for anybody to try Milo. We want you to see the value before, like, you're not committing to this black box AI tool that looks shiny and interesting. We actually say, no, try it with your students, try it yourselves. You know, it's really, really worth the value of having a tutor sit by your side that can ask any question. And we provide it as an optional add-on, so we don't force people to kind of pay the extra cost for it. And we provide it at cost. So we're providing it for just $5 per student per year, which is really just the cost of the API calls to run Milo. So equity is a big thing for us. We think this is really the future where AI is headed. The results have been phenomenal as students have been using it. So we think we want to make sure that this is something that's available to everybody. Okay, and then the last thing with our approach is we're as scientific as possible. We A/B test everything as we're going through. How much time do I have? Yeah, it's really worth showing you this to give you an idea of how scientific we are with our approach. This is an example of our A/B testing platform. We have a control and a variation. So what's A/B testing? We get some students, in this case, 75% students are on the control and 25% are on this variation where we're testing something else. With this particular one, we were testing having the hint video example at the bottom of the page for students to click on versus, let's move this aside, X, versus having them sit up there so that they are conversation starters with Milo. Can I get help? Can I get video, a hint, an example, right? And then we look at the results. So 25% of users are on our variation, and we put the metrics that we care about. So are they using our help options more? Like, yeah, that increased by 8%. Are they using the particular help videos more? Are the number of help options used increase? So are the number of students using it increasing, and are the number of times they're using it increasing? And you see, yes, they're both increasing, and it's statistically significant in terms of the thing. So this is an example of one where this experiment really worked. The number of skip steps, are students skipping steps on this new variation, and they're skipping steps a lot less. So they're using help options more and skipping steps less. And so we can really see that this is an experiment that's working really well. And so I think in the next week or so, we're going to release this to everybody. So you will now see the help options sitting as conversation starters. And we can hypothesize as to why the reasons are. And part of the reasons why we believe that this is the case, that students are using it more and skipping steps less, is because we are encouraging them to start by using our hints, but then continue the conversation with Milo. And when they continue the conversation with Milo, they're less likely to just say, I give up, I skip a step, but they're more likely to get those questions correct. And we see that reflected here as well in terms of the amount of the task mastery improving and the problems per mark increasing. So this is our approach at Mathspace. We don't just kind of like, oh, that's an interesting feature. It's like, okay, we think that's a great idea. Give the team room to experiment. Try it out with a small number of students. You know, we started this with 5%. It worked really well. We increased it to 25%. And now it's like, oh, we've got a lot of confidence. We're going to roll this out to everybody. And we do a similar thing. We did a case study of our students' chats on topic. What we found is if conversations go for more than 10 messages, then 53% of the time they go off topic. I'm like, oh, wow, we don't want to have these really long conversations where students just start chatting with Milo and asking about the weather and asking about things like that. What should we do about this? There's a 50-50 chance that when they have more than 10 messages, that they're not really working on the maths anymore, they're working on something else. So our approach now, we've built this into the product now, and you might have noticed it, is if conversations are off topic, after 10 messages, we use another AI to look at the history of the conversation and say, is it on topic or off topic? And if it's off topic, then we end the conversation and we say, it looks like it's getting off topic. If you keep doing this, we're going to alert your teacher. And we've managed to get students a lot more on topic, and we're also just stopping those endless conversations. So it's kind of the approach that we take. And so what are the results? Well, students' engagement with help has increased by 30%. Accuracy after chatting with Milo has increased by 20%. and 68% of students would miss Milo if it was taken away. This is a little bit old, this data. I want to get some updated data on this. I think they probably improve even more since we've done a lot of work improving Milo. Okay, so yeah, that's kind of where we see the intersection. So we're coming towards the end of our time. I know that some of you wanted to see the full, I've given you kind of a bit of a demonstration, but for those who want to stick around, we can go in and actually see live and do some practice problems with Milo, and we can kind of go through that. But I'll turn to questions for anyone that has to leave now, and then I'll move to that. That's a great idea. Offer a prize if they find hallucinations with Milo. They're happy to let us know. Students are very direct with their feedback. Can we get Milo standalone if we're committed to a different textbook? Yeah, I'll let Fady kind of answer what that means. So you can't get Milo without Mathspace. We have different packages of Mathspace, but Milo is just an add-on to. You could be on the very basic package of Mathspace or the full Mathspace digital textbook, and Milo's an add-on on top. Okay. Are there any other questions that you see? I work with students in online space, what prevents them from using AI to solve mathematical problems in a test assignment, prevent it as their own work? You pretty much can't stop that. I mean, cheating has been around forever. You, as a teacher, you just need to have other methods to kind of really check students' work. Obviously, on Mathspace, one of the things we say about Mathspace is we want to make it easier to learn than it is to cheat. So why does a student cheat? Well, a student cheats because it's too hard, it's going to take too long, they don't know how to do the question, etc. So it's like it's easier to cheat. It's the kind of easy way out. But right now, with the way we've integrated Milo into Mathspace, we're encouraging you to cheat in a healthy way, to cheat without giving you the answer. So we are seeing that students are, well, I can just go to ChatGPT or Wolfram Alpha or whatever and ask this question, but I've got the help right there. And I can just ask the question and it'll help me as I'm going through right there. It'll have context of the question. It'll have context of everything that I've tried as I'm going through. So as long as you have a good relationship with your teacher, where it's like, this is more about learning than about assessment, then there's the fact that the teacher can see that you've used the help shouldn't be a problem. So that's really kind of where we want to go with this, and how I would encourage you to approach it with your students, that this is a space for learning and there's a different space for assessment, and that will probably be still on pen and paper and with no computers and all of that, and probably increasingly so. But while you're learning, go in there and use the help tools on Mathspace, like cheat, use Milo to cheat, is basically what we want them to do. And we've put all the guardrails in place to make sure that they are learning. They're not cheating to the point where they're not learning, where Milo just pushes back on that. Okay, concerned about literacy levels. Milo seems to require high levels for students. Yeah, so one of the things we've done is we've made Milo a lot more concise, and so I'll show you a little bit of that when we get into the demo. So it's generally Milo will most of the time reply with 2-sentence and very short responses to help with that. But also we're looking into text-to-speech, the ability to speak to Milo. If you've seen any of the demos with OpenAI, that stuff is coming soon. It's not released to like the public, to developers like ourselves, but it's imminent. They demonstrated it a few months ago and it looks amazing. So we're very keen to try that out when it comes out. Okay. All right. For those that have to go, thank you so much for attending. For those who want to stick around, we'll do a quick dive into some of the Milo's capabilities. Okay, let's see. I might start with a question on distributive law. I have a lot of tabs open. There we go. Okay, so yeah, you can see here I've got my video hint and examples, and I can kind of use them. One thing I want to show with this one is this new feature that we've been working on. If I put -4p, what's the common mistake that everyone does with this is -4p, -3q. So I put that in. So a new feature that we've introduced to encourage people to chat with Milo is Milo comes up, you put a wrong step in, it's not quite right. Do you want to explore why together? Yes, please. And then we get this, so one of the things we need to train students to do is to ask the right questions. So here they say, can you explain why that was incorrect as they go through that? And Milo comes in, goes, when you expand the expression with a negative in the front, you need to distribute a negative sign to each term inside the brackets. So really specific on the question that they have. The other thing that we've done a lot with Milo is to end the conversation with a question. So what happens to each term inside the brackets when you distribute the negative sign? And they can write something like become plus. Not quite. When you distribute a negative sign, each term changes its sign. Oh, okay, great. So then the first becomes negative and then the second becomes plus. So it's like, what happens to the term 4p? And you can continue minus 4p. Exactly. Now look at the second term, the minus 3q, and they can say it's plus 3q as they go through. So this is a safe space as well, where they're not getting graded. So sometimes students are a bit scared to put incorrect answers in here because they just don't want to see a cross on their screen as they're going through. But this is a safe space where they're going through and they can go through, and now they can put their answer in when they're ready and move on. So cool. So that's an example of one. I'll do one more example and then I'll kind of turn it to the audience if you have any kind of specific questions or want to look at a specific ability of Milo. One thing that we've started to do a lot is add images to Milo so that Milo can understand the images. Now, in order to do this, we have to actually describe the image to Milo. So there's a lot of work involved in doing this. We've now got maybe 20% of our questions with images have Milo chat. Sometimes you'll see that Milo says, I'm not ready I haven't learned how to answer these questions yet. So you can still use the hints and videos, all the things that you can do on Mathspace, but you can't kind of chat to Milo directly. So one of the things I want to show with this is a student can go through and ask for a hint. And then we provide our teacher written hints as we go through. They ask for another hint. And in our hints, and this is one of the benefits of this, in our hints, we have included the images as they go through to really identify what those surface areas are. And because we've described the images to Milo, you can actually ask questions about that. So you can say, so the green triangle are a half times, let's get this wrong and see if Milo can pick it up. A half times 5 times 6. They should be a half times 4 times 6. And then Milo's good enough to say, let's take a closer look. The base of the triangle is 6 and the height is 4. So the formula is half times base times height. Can you calculate the area of one of the triangle faces using this information? And you can see just how specific. This is, really getting to the level of the teacher sitting right next to you. And one of the things I've observed when I visited schools and watched the students using Mathspace, I sit next to the student and I say, look, I'll help you as you go through this problem. And I go through the problem and they're like, what do I do next? And I say, don't ask me, ask Milo. And they go through and they ask Milo, what do I do next? And it's basically replicating what they would say to me as they're going through that. So yeah, it's really getting really good at drawing the entire context of what the student has put in, the question, the solutions that we have, and being able to provide very, very specific information to students. To me, it really is it's a no-brainer in terms of the value that we're talking about. For $5 per student per year, where you'd pay a tutor, let's say $50 per hour to help you as you're working through your math problems. We're talking about not $50 per hour, but $5 per year on any questions that your teacher has assigned you in Mathspace. It's not quite any questions because, like I said before, some of the questions we're still developing the ability for Milo. And we only turn on Milo when we're very confident that it's going to give good answers. So that's another part of the reason why when we're not like, oh, let's just turn it on everywhere. No, we want to make sure that when we have turned it on, there's a very high chance that it's going to give great responses to the teachers. Okay, so I'll end there with some of what Milo can do. Of course, the standard things of can you just give me the answer, just to give you an idea. Milo will always push back and say, as a math tutor, I'm here to help, but I need you to try before I provide more help. So that's something that we've been really forceful with, making sure that students aren't just using this to kind of work their way and get an easy way out. Yeah, the question about audio, that is as soon as OpenAI kind of opens that up to developers, because it is something that they've worked on, we will be on it like a rash. Yeah, we are very, very excited about that possibility for it to read aloud. One of the things that we have done, I might show you, just to give you an idea of like, yeah, we're very quick to experiment with anything that comes out, and we're really quick at developing it and putting it into product. I think hopefully anyone that's used Mathspace can attest to that. So translating to Spanish is an example of something that's a recent thing that we just released today in beta. So if anybody does have a lot of students who speak languages other than English, reach out to your school consultant. And this is something that's coming on the horizon soon for multiple languages. We've started with Spanish because we have schools in the US where the Spanish speaking population is like 50%. But yeah, you can kind of translate to Spanish. And this is quite a difficult problem to solve well. You can see over here, we've translated that question to Spanish for them. So yeah, really, really excited about this. This will include if there's images, if there's things like that, if there's tables, if there's graphs. That was the difficult part to solve. So we've always been able to just like use Google Translate to translate, but now we're able to translate into context, which is amazing. So that's another thing that we've been working on. Text-to-speech is definitely one of the other things. Translation to Arabic, yeah, a language that I speak, so I'll be the guinea pig for that one. So we started with Spanish, but yeah, Arabic I think would be a good language. Although a lot of the I don't know how well the Arabic maths translates. Like I think we do algebra with Arabic letters and things like that, so that'll be kind of interesting. Awesome. Okay, thank you so much for all those that hung around to the end. If anybody has any further questions about Milo, wants to try it a bit longer, reach out to your school consultant. We are all about making sure that you think this is as great as we think it is before adding it to your subscription. If you are not currently a user of Mathspace, but this really piqued your interest, we're really leading the way in terms of what it means to be both a digital publisher and a textbook publisher, but also take the best of the digital and the best of technology. And like I said before, working very, very closely with the educators to find that intersection where it's going to actually transform the maths classroom. Awesome. Thank you so much. And I'll catch you all soon.